This is the unpacking of the Mars 36 Atlas, read by the voice clone of the editor, and a semi-controlled translation from Hungarian. The atlas was supported by the Europlanet Central Europe Hub. 10 atlases, just out of the printing house. So let's start with the front page. It shows the pimples of Tharsis rise or Tharsis bulge. The number 36 indicates that this is the 36th edition. No, this is the first edition. But for Mars year 36, right. Year 36 on Mars begins in February 2021 and it will end on the 26th of December 2022. That is, 1 year on Mars lasts roughly 2 Earth years. Page 4 shows the calendar for Mars year 36, in which the information necessary for the Martian harvest can be read. That is, when the windy, dusty, or even the frosty season starts and ends. This is very important information for people of Mars, especially to know about the dust storm period. Of course, perhaps the concern is too early, as no one lives on Mars yet, as it is shown on the information board on page 5. Here we can compare 3 maps of the same area. Important, this atlas is a geographical atlas. It has geographical approach. It is not a photomosaic, not an elevation map, as you may have seen such maps of Mars. Instead, it is similar to physical geographic atlases you already know from school. In this atlas, for the first time, yes, it shows a topographic map as background plus landforms created by water, wind, volcanic lava, or ice. This is the first atlas that can do this complex display, and the result of many planetary geologists and cartographers, as shown in the legend, with full references to the publications about each landforms. In the legend page, each landform is also shown in a small image. The albedo map of Mars shows the dark and light spots as you can see them through a telescope from Earth. These albedo features are only visible when the shadows are short and the sun is shining from above. This is the standard theme of 19th century maps, but this one is not the same as the old maps, because the shape and size and brightness of those markings have changed since then. This map is using spacecraft images made between 1997 and 2012. The next pages show the same but on a topographic map. Topographic or elevation data is known only since the 1960s, when it was visited by spacecraft. The small maps show the lowland and highland hemispheres, much like the Earth that has one mainly oceanic and one mainly terrestrial hemisphere. By the way, the area of Mars is just as big as that of terrestrial lands. That is, there are as much area to map as there are on Earth's continents, not counting the seafloor. The next page has the weather map. Here, both round maps show the same area, just one in winter and the other in summer. The calculations were made in various fast food restaurants near Nyugati railway station in Budapest, just before the second wave of COVID-19. There are 3 little bubbles for the temperatures, all in Celsius degrees. The researchers otherwise hardly use. One value shows ground level highest temperatures, and the other shows the same at 2 meter height. At only o'clock local time, the lower bubble shows the lowest temperature around 5 a.m. As you can see, the difference between ground level and 2 meters can be up to 40 degrees. It is shown in this drawing made by my daughter. The difference is due to the rare atmosphere and the rocky desert. Although such a situation does not exist on Earth, but in the deserts, for instance in Australia, the rocky ground can be as hot as 70 degrees Celsius, while the air is only 40 degrees hot. If there were no grass or other plants, it would be common on Earth that the temperature of the ground level is quite different from that of the air, as is the case on roadways, for example. So thank you for the vegetation and the relatively thick atmosphere that our shoes don't melt. The next page shows the index maps and there is a figure that compares the silhouettes of the mountains. Then the map sections start, a total of 30 Mars chart or MC quadrangles at approximately 1 to 10 million scale. MC1 shows the North Pole, where it can be seen that the ice cap is surrounded by a ring of sand. The map does not show that the sand is black everywhere, because it is made up of basalt grains. It is not common but also not unheard of on Earth. For example, there are black beaches in Hawaii. But the sand is black everywhere on Mars. The dust is bright colored, but the sand is black. Ice is white everywhere except when it's mixed with dust. Then it is pale yellow colored. MC to the northern lowlands, flat land, but this is largely lava flows here. The newer the smoother. MC3 we turn and see Olympus Mons, where the sky is often cloudy, and this area is quite cold, characterized by volcanoes, lava flows, pit crater, Hygens Basin, where most of the outflow channels flowed at the time. Then Table Mountains region, or the messes, the transition between the northern lowlands and the southern highlands. The aprons preserve traces of ice everywhere. This area may have once been under thick ice, many traces of which can still be seen today. On the MC6 section is the Utopia Basin, which is an ancient impact basin, 5 kilometers deep, but due to deposited sediment, the original crater form has completely disappeared. This is where the muddy streams from the Elysium flowed, which are even more visible on the next page. Now we jump back to the starting point or starting longitude, but now the equator is the bottom latitude on these charts. On the first sheet this is the volcanic Amazon plain, or the plain of the Amazons, with wind-blown or rolling forms in the south, which are very rich in yardangs, wind-sculpted rigs and troughs. And of course the most striking form on the next page is Olympus Mons, the highest mountain on Mars, and quite a few more volcanoes on the Tharsis Ridge. The small red symbols indicate cavities from which you can enter caves, which are mostly lava tunnels. Cavities are known from their bottomless shadowed pits even near noontime. To get to the east side of the Kryze Planitia, we crossed to the great outflow channels. There was once a lot of water lost here. The floods cut beautiful streamlined islands for themselves out of the loose regolith, or soil-like fragmented rock. The desert, in other words. No roots to cement the rocks and dust. This is the starting place of the ancient, crater-covered highlands. First, Arabia Terra, and the other Terra, where you can already see the valley networks, at the bottom of which water once dripped. But of course they are all dry today. Cratered highlands and valley networks usually come together. The both are as old as 5 to 4 billion years. Syrtis Major is here, which is also the darkest spot on Mars. This is the Perseverance landing site. At least this plan, 2 more weeks from now and it will land here. Well, not exactly here. It is just a book and too small for landing. The landing will take place 200 million kilometers from here, on Mars. Elysium Mons, the other big volcano on Mars, and Orcus Patera, a strange crater that probably came at a very flat angle, scrubbing the surface, and we almost slipped over it. But a lot of lava and our water flowed out of the Cerberus fault lines or fossa, which form these outflow channels here. They are an important feature on Mars, because these channels contain the most recent lavas of Mars just a few million years old, which counts here as very fresh. Mart Vallis and Athabasca Vallis are 2 of them. Let's cross the Martian equator, which is now the northern bounding latitude. Vales Mariner, the great crack full of landslides, and south of it the Themasia Plateau, with folded ridges, or wrinkle ridges. We approach Argyre Planitia, or Argyre Basin, a large impact basin, and here is a complex network of valleys, starting from the south, the Uzbo Vales through Holden Crater, Ladin Vales, Ladin Basin, Morava Vales, Margaritifer Basin, and then to the north the Ars Vales flowed into the Kryze Basin. Our next stop is at Erie 0, a crater exactly on the 0th longitude, the starting meridian. It was named after Erie, George Erie, who put the Earth's starting meridian in Greenwich, when he was a royal astronomer in 1851. The larger crater is called Erie. The smaller one is Erie 0. Here is another talking name. The Scylla and Charybdis scarps facing each other as in the ancient mythology. I wonder who will be the first person to walk or drive through them. On the MC21 chart here is the Hygens Crater, a rare ringed crater on Mars, with plenty of valleys on the outer slopes, but not one inwards. The southern, densely cratered highlands are flooded by lava in this region called Hesperia Planum, and in the middle here is the source of lava, Tirrenia Potera, a volcanic mountain and caldera. Quadrangle 23, the Curiosity landing site at Gale Crater with a huge hill in the middle. Then here are highlands, craters and pale river valleys, and the Tharsis Highlands, which is the only special mountain something like Tibet, and the Himalayas. But there is significant volcanism here, which is not in the Himalayas. So volcanism can also play a big role in its formation. And this is home to the densest valley system, the Warrego Valleys, which is also the highest valley system, at 8 kilometers heights where the atmosphere is really much thinner than on the surface. I mean at the mean elevation. MC26 displays Hygens Basin, the smaller one of the large southern basins separated from the other large basin by Noches Terra, followed by Hellas. Hellas Basin is the deepest and largest basin, and also the oldest, for a billion years old, which has an eroded rim and a filled inside. The material that filled it was eroded from its margin, of course. We continue in the southern cratered zone, and finally reach the Martian Antarctic, with no continent because there are no continents on Mars, it's just one plate. The South Pole has a much smaller permanent polar ice cap than the North, and here there is no sand ring, but you can see a semi-buried giant impact basin, Prometheus, half of which has settled the ice material of the South Cap. There are 2 more close-ups of the polar caps in the atlas, and climate maps, cloud maps, and finally climate diagrams and climate zones map, which was the hardest job to figure out how to design and on what basis, and what the summer and winter and autumn and spring means in a Martian context. I mean in terms of weather and climate, and not astronomically. From the diagrams you can see how devastatingly cold it is every night. Approx. Minus 100 degrees everywhere. But there are large differences in the course of the maximum temperatures, which sometimes reach 30 degrees Celsius or 90 degrees Fahrenheit. But that's the ground, not the air temperature. Rocks can get as hot as this, but not the air. So, to conclude, there is no such thing as Mars in general. Mars has places, specific materials like sand, lava, dust, and climate and daily weather that vary with the seasons. Oh yes, there are seasons. Places with 4 seasons, and places with only 1. And the last pages shows the seasonal changes of the polar caps, like the beautiful flower petals. The back cover is also interesting. We approach a Barchan, a croissant-shaped sand dune, and small numbers here indicate the scale. You can see how the albedo patterns are resolved into individual forms as we zoom into the surface. Thank you for watching. We look forward to your suggestions for next year's atlas. The address is planetarymaps@mail.com. Oh, and if you post something about the atlas, use hashtag MERS36. No spaces. Thank you.